All right, here we go. Question 21 from our Calculus 1, homework number 3 in WebAssign. Here they have given me a function in terms of r, and they ask me to find the derivative. So what I've done is I've recopied the function into my notes. Maybe one of the first things you want to notice is that this is a rational function. We've got a numerator and a denominator. And so what I'm going to do is I'm going to assign the numerator to be f of r and the denominator to be g of r as their own separate functions so that we can hopefully keep the quotient rule straight as we find the derivative. So finding h prime of r, which I would like to note that that is the same as saying dh dr. In other words, finding the derivative with respect to r. Using the quotient rule, that is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. That is your quotient rule. That's what we're going to apply to calculate this derivative. Using the quotient rule, we need to take the derivative of the top first, and the derivative of e to the r, think of it as e to the x if you want. The derivative of e to the x is e to the x, so the derivative of e to the r is just e to the r. That is the derivative of the top, and then we need to multiply that by the bottom. We're just going to copy and paste b plus a e to the r, and that takes care of the first product. And then we have a minus, and we need to copy f of r. So then that's going to be just e to the r times the derivative of the bottom. So remember that b is a letter, but since it's not r, it's going to be considered as a constant, and the derivative of a constant goes to 0. So we lose the b in the derivative, and the derivative of a e to the r is simply a e to the r. Now, on a side note, why is that? If we look at a similar example, remember that a would be considered to be like a constant. So this would be the same as maybe consider the derivative of just 2e to the x, where we know that if you have a number multiplied by your function, when you take the derivative, that number, that coefficient, can be pulled out front, and then you just take the derivative of e to the x. And so that's how that becomes just a e to the r when we take the derivative. And last, we need to remember that the denominator is going to be squared. So we're going to have b plus a e to the r quantity squared. And that technically is done with the calculus, but we would like to use our algebra skills and try to simplify this a little bit. Notice that this, that I put the red box around here, that is all one term. And this guy, this is also a single term. And if you notice, those terms have a common factor of e to the r. So I'm going to factor that out. Here we go. Our derivative, h prime of r, factoring out the e to the r, would leave me b plus a e to the r minus a e to the r all over the denominator squared. And some of you have already noticed what's going to happen inside the parentheses. That's right, the a e to the r's are going to subtract out and make 0, leaving me only the b, which remember that is considered to be like a constant. And so we can simplify this. This will be our final step here. Rewriting that as b e to the r all over the denominator quantity squared. And then if I minimize that, you can compare our result here with the result I got in class and see that it's the same. And so that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.